Hi guys, this is my lesson on improper integrals, lesson 10.2, and I want you to know that I just did the entire lesson already, thought I was recording it, but no, I simply took a picture of the very first page. So I already did the whole entire lesson. Here it is, ha 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 ha. So funny, now I have to do it again. Please take a moment to pause and make fun of your stupid math teacher. Hope you enjoyed that. Now I'm checking. Yeah. It appears to be recording. Yep, numbers are moving. Okay, good, awesome. All right, improper integrals. Here we go. All right, so I only kept this page that I already did the lesson on so that you could see my definition of improper integrals. But in all honesty, I don't really care if you have a formal way of remembering what they are. I'm going to show you what they are, and I think it's pretty easy to remember. So these same problems that I have prettily typed, here they are again, but not so pretty because I couldn't print out my PowerPoint again since I'm no longer at work. All right, here are the three cases of improper integrals, okay? So basically, the issue is, to be an improper integral, either you have an infinity of any sort in either of the two bounds. If you have an infinity in one of the bounds, already that's an improper integral, okay? Or one of your bounds leads to division by zero, like this. So the 4 here makes this one improper. So this was case 1. This is case 2. Case 3 is a little harder to recognize. Here you can't divide by 0, but neither of these are 0. So can you figure out why this one is improper? Anybody yelling at me, talking out the answers, pretending I can hear you? This one is improper because division of 0 you can't do, and 0 is in between -2 and 1, okay? So now let me show you real quick how you fix each of these problems, okay? And then I will work them out nice and slow. So the short of it is this. To fix the issue, you're going to cross off the problem, which is in the bound. I'm going to change this infinity, change it to any variable you like. I always use the variable b if it's the top bound, the upper bound. So I'm going to change that to a b, and I'm going to plop a limit out in front, the limit as b approaches whatever was really supposed to be there. That's how you fix this problem. Replace the problem with a variable and pop a limit out front. The second case is going to be fixed kind of the same way. The issue is the 4, because we're not allowed to divide by 0. So cross off the 4, change it to a variable. I always use a for my bottom bounds, and stick a limit out front. The limit as a approaches that number which was there. So as a approaches 4. Now I've got to show you a little bit more. Sometimes you can get away with just leaving it 4, but to be safe, I always write whether it's the limit approaching 4 from the left or the limit approaching 4 from the right. So how do you figure that out? Well, think about area. This says I want the area between 4 and 7. So I don't need any of the numbers to the left of 4. I only want from 4 and to the right of it until I hit 7. So this would be the limit as a approaches 4 from the right. Okay, and I'll explain more about that in a little while. Okay, option 3. Here, the issue is 0. You can't divide by 0, but 0 is within these bounds. So for this one, it's a little trickier. You're going to break this into 2 different integrals. One that goes from -2 to 0, and one that goes from 0 to 1. So I'm going to integrate from -2 to 0, 1 over x squared, plus I'm then going to integrate from 0 to 1, 1 over x squared. Now, that doesn't really fix the problem yet, because the problem is the 0. The 0 is what I'm not allowed to have. So I'm basically going to do the same thing I did over here, but I have to do it twice, once for each of these. So here I'm going to replace the 0 with a b, just because I like my upper bound to always be a b, doesn't have to. And it's the limit as b approaches 0, and which side of 0 do I care about? We're going between -2 and 0. Between -2 and 0. After that, I don't care about it. So it's between -2 and 0 is approaching 0 from the left. This one, the 0, change that one to an a, and the limit as a approaches 0. And this goes from a to 1. So I care about between 0 and 1. This one I want to the right of 0, between 0 and 1. So this would be from the right of 0. You probably can figure out that if it's an upper bound, you want to go to the left of it, and if it's a lower bound, you're going to want to go to the right of it. Okay, that was me just warming you up with this is how you fix the problem. The rest of this is really just going to be evaluating limits, which you've already done many of them. Sometimes you have to use L'Hopital. Sometimes you get answers of infinity. Sometimes you get numbers. So pause for a minute, catch up with my notes. The next thing I'm going to do is work these out nice and slow for you. Okay? So hit pause if you have to catch up on your notes or ask each other any clarifying questions. Okay? Okay, so I will be working out 4 problems for you today, and I'm sorry, but it's going to take me a little while to do it. So we have 4 problems. I'm going to do 1 of each type of these and then just 1 more. You'll see why when we get there. So we're going to start with this exact problem that I wrote down here, option 1. Okay, we already discussed that the issue is you're not allowed to have infinity as a bound. Now I'll be honest with you. If you integrate this like normal, and then you just stick in the infinity because you want to, you'll still get the right answer. The only problem is if it's a free response question, they won't let you do it that way because technically infinity is not a number, so you're not supposed to be able to do that. But this is the easiest type of problem. Okay, replace the infinity with a variable. I make it b, pop the limit out front, the limit as b approaches whatever that was that's there, infinity. Okay, now integrate like normal. I'm going to rewrite this as x to the negative 4 from 1 to b. Now integrate. Add 1, you'd get x to the negative 3 divided by negative 3. And I'm going to pretty that up a little bit. That goes from 1 to b. So make this negative exponent positive, put it on the bottom. So I have negative 1 over 3x cubed from 1 to b. And this limit that I have way up here, I was supposed to bring it down here. I was supposed to bring it down here. And I definitely have to have it here. Okay? Now, I'm going to, let me move up here. Now I'm going to plug in b and 1 for both of my x's, like normal. Absolutely must have that limit now. Right before you evaluate the limit, you've got to have that limit written there. And I'm going to replace the x's, well, the 1x with a b. And then I'm going to replace the x with a 1. So it's negative 1 over 3b cubed minus negative 1 over 3, plugging in a 1 would still give me a 1. Okay, hopefully you're with me. Not too much longer to go. We're almost done with this one. Now I evaluate this limit. Plug in the infinity right here in your mind. Take infinity, cube it. It's still infinity. Times 3, still infinity. A constant, whether it's positive or negative, a constant over infinity goes to 0. Hopefully you all yelled that out. So we now have 0 for this term. Then this doesn't even have a b in it, so it's just plus a third. So my answer is just 1/3. Which is hard to really imagine that this, if you think about area, this was an unlimited area, starting at 1 and going forever to infinity. But what it comes down to is does it slowly get close enough to 0 that I can get an area even though it technically doesn't stop growing? Kind of hard to explain. I'll show you more in a little while. That's option 1. Hit pause, chill, ask each other questions to clarify. Now is a good time. Okay, example 2, the same example that we did on the very first slide. There are 4 examples total. Sorry about that. All right, example 2. The 4 is the problem because it results in dividing by 0. So we already discussed, get rid of the 4, change it to an a, pop a limit out front. The limit as a approaches the number that was there, 4. And we want between 4 and 7, so I want to the right of 4. Okay? Integrate like normal. Well, actually, let me rewrite it pretty first. This is the integral from a to 7 of x minus 4 to the negative 1/2. Still have the integral symbol. I'm still supposed to be bringing down that limit every single step of the way, but I hate writing it. Okay, do the antiderivative. add 1, and divide by the result. So I have x minus 4. Add 1 and we'd get, add 2 over 2, we'd get 1/2. Divide by 1/2, same as multiplying by 2. And I'm going to rewrite this real quick. This is 2 times the square root of x minus 4. Evaluated from a to 7. Okay, make sure you get that limit written down, the limit as a approaches 4 from the right. Okay, and now I plug in the 7 and I plug in the a and I subtract. Plugging in the 7, I would get 2 square root of 7 minus 4 is 3. Minus, plugging in the 4. Now, when I say plug in 4 to the right of 4, most of the time you just plug in freaking 4 and you ignore that plus sign. If you can't plug in the 4 because it results in dividing by 0, then you plug in a number really close to 4, but to the right of it. Okay, but your first step is to just try plugging in freaking 4. So if I plug in a 4 right here, it gives me 4 minus 4, which is 0, and I can do the square root of 0, it's 0. So this whole thing is just 0. That's fine, that's not a problem. So I didn't really have to do anything with that plus. So now that I evaluated that limit, I actually kind of screwed up. That limit should have been up here. This is where I really needed it. Here I don't need it. We don't have any variables anymore. Sorry about that. So my final answer is just 2 square root of 3. Done. So pause, catch up, ask questions, and we'll be moving on to example 2 in just a little while. Okay, I have no idea what I just said. I think I said we're moving on to example 2, but that was example 2. Yikes, remember this is my second time doing this lesson within the last hour. Example 3. All right, so first, write it down and see if you can figure out how to fix this one. This is not one of the ones that I actually had written on the first slide when I first introduced improper integrals. So hopefully you can figure out how to fix it. I'll take a minute while you do that. Okay. Every time I say pause, it's up to you whether or not you guys actually need to pause. It's hard for me to tell how fast to teach something when I'm not looking at your faces and I can't see whether or not you're still writing. So pause whenever you want to. All right. Hopefully you figured out that the issue is you cannot let x equal 1. If x were 1, you would be dividing by 0, which no can do. But the value 1 is in the middle of my improper integral. This is the one that catches students a lot, and they go and they try to integrate like normal, and they try to plug in the 3 and the 0 at the end, and it just does not work, and they get this dramatically wrong because it's hard to recognize that this is an improper integral. So the problem is that x can't be 1, and 1 is in the middle of that integral. So this is the kind of problem where you break it into 2 separate integrals. I'm going to integrate from 0 to 1, x minus 1 to the negative 2/3. And I'm going to integrate from 1 to 3, the same thing. Okay, so this one takes over where this one left off, so these are equivalent. All right, but as I said earlier, that still doesn't fix my issue. The issue is x can't be 1. So now replace those ones, and you could have done it at the same time. I do it as 2 separate steps. It works for me. I don't know. Replace this 1 with a b, and it's the limit as b, as b approaches 1 from the, what, left or right? Hopefully you all yelled out, left, because you want between 0 and 1. So you care about what's to the left of that 1. This one, the 1 is still a problem. I'll replace it with an a. Again, it doesn't really matter what variable you use. And pop a limit out front. It's the limit as a approaches 1 from the, we want between 1 and 3, so that one's from the right. Okay, now, you're basically going to integrate both of these like 2 separate problems, okay? And then add the 2 answers, just like it says. So, integrating this one would be x minus 1, add 1, you'd get 1/3, and divide by 1/3 or multiply by 3. And this is going to be evaluated from 0 to b, and I have the limit as b approaches 1 from the left. You could actually work these as 2 totally separate problems. Okay? I'm going to keep going with this part first. Now I plug in the b. You get 3. This 1/3 is really a cube root, so it's the cube root of b minus 1. minus plugging in a 0. This is 3 cube root of 0 minus 1, which is negative 1. All right, now evaluating that limit, plugging in 1 or left of 1 if necessary. Can I plug in, start by just plugging in 1, forget that negative, or it's not really a negative, forget that from the left. Plugging in a 1, you get 1 minus 1 is 0. Cube root of 0 is 0. That's okay, no problem. So this is 0. Cube root of negative 1. Can you do the cube root of a negative? Sure, this is negative 1 times negative 3, which will give me 3. So my answer for this piece, this is just the left piece, is 3. All right, now doing the same thing for the second half. I'll switch colors so maybe you can tell the difference, but don't forget you need a plus sign to connect these two answers in a minute, okay? So this we're going to do the same thing. I have the same exact antiderivative, so it's still x minus 1, or to the 1/3 divided by 1/3, evaluated from a to 3, and it's the limit as a approaches 1 from the right. Plugging in the 3, I would get 3, this is cube root, times the cube root of 3 minus 1, which is 2. Minus, plugging in the a, and I'd get 3 times the cube root of a minus 1. And now I have to plug in my limit, the limit as a approaches 1 from the right. Okay, plug in normal 1, forget from the right, unless you have to use the from the right. Plugging in a 1, you get 0. 0 times 3 is 0. So this one just equals 3 cube root of 2. Just don't forget, you were supposed to add these two answers together. So these two added together would be your final answer. And these aren't like terms, so all you can write is that this is 3 plus 3 cube root of 2. Whew, I'm whooped. Hope you guys are hanging in there. Sorry, so boring. All right, that was example 3. I have one more example to show you. Not because its process is different, but because I need you to know how to interpret the answer at the end, okay? So far, all 3 of the problems that we've done all resulted in a number. You've got a finite number, an actual number. Well, since we got a number for all of these, we could say that the integral converges. You may not need to really remember that right now. But if you don't get a number and instead you get infinity for either piece or for the total, if you get infinity as your answer, then you'd say that the integral diverges. And that's why I have to do the next example, which kind of tells you what the next answer is going to be. So pause, ask each other clarifying questions if you need to, catch up with your notes if you need to, and I'm going to go on to the last example, example 4. All right, last one. First, write it down, and you figure out what makes this integral improper. Okay, did you figure it out? You can't divide by 0, and 0 is one of the bounds. All right, so cross off that 0, change it to a variable. I like to use a when it's the bottom bound. I have no good reason for that. And pop a limit out front. The limit as a approaches that number, 0. And which side of 0 do I care about? If I'm going between 0 and 2, then I care about to the right of 0. 0 to 2. So this is going to be from the right. Okay? Now actually integrate. This is the same as, I'll rewrite it so that we can integrate more easily. This is the same as x to the negative 2. And I have that stupid limit written the whole way, pain in the butt. All right. Now do the antiderivative, integrate. Add 1 and divide by the result. You get x to the negative 1 divided by negative 1, which hopefully you guys know right off the bat, that's negative 1 over x. Evaluated from a to 2. Okay, and again, I have the limit as a approaches 0 from the right. All right, plug in the 2, plug in the a. I'm going to move up here now. Plugging in the 2, I get negative 1 over 2 minus, plugging in the a, I get negative 1 over a, and I have that limit. Now that limit has to be here, the limit as a approaches 0 from the right. Okay, now what the heck is this going to be? I have negative 1/2 plus 1 over a as a approaches 0 from the right. Well, what will this equal? If I plug in 0, first you try to just plug in 0. If I plug in straight 0, you're dividing by 0, you can't do that. Now that from the right really matters. So what would be a number that's to the right of 0, but really close to 0? You might think 0.1, 0.01, 0.001. That's true. You could use all of these numbers. They are close to 0, but to the right of it. But it's actually way easier because this is a fraction. You want to really do these as fractions. So let's try thinking about, as a gets larger and larger, what happens to the value of this whole fraction? Well, instead of 0.1, think of 1/10. This would be 1 over 1/10, and 1 divided by 1/10 would be 10. Okay, put in 100th. This would be 1 divided by 1 over 100. 1 divided by 1 over 100. Multiply by the reciprocal, that would go to 100. Let's go to 0.0001. That would be 1 over, heck if I know, 10,000, I think. And that would be, when you put 1 over that, that's going to go to 10,000. So hopefully you're getting the idea that the smaller we get to 0, the closer we get to 0 with my a value, the smaller the a gets, the closer we get to 0, the bigger the total fraction becomes. So this guy right here, as a approaches 0 from the right, this term right here is going to go to infinity. So we now have -1/2 plus infinity. If I'm at infinity and I subtract a measly little 1/2, that is still infinity. When you get infinity as your answer, and it's not a nice, neat, finite number, then you say that the integral diverges. Okay, you may need to see this written out again more slowly. You guys can pause if you want to. The short of it is this: if you get infinity for either piece, let's say it was that last problem where you had 2 pieces, if either of these go to infinity or negative infinity, then the integral diverges. All right, so I'm done with all my examples, but because I didn't have my pre-made PowerPoint, I forgot to show you the graph that I wanted to show you. This is the graph of, I don't know, you tell me, is this the second or third example? Yeah, it's the third example. This was the third example, okay? This graph that I'm showing is the graph of 1 over x minus 1 to the 2/3. There's a vertical asymptote at 1. And you know that area from 0 to 3 means I want the area under the curve, between the curve and the x-axis, from 0 to 3. But if there's a vertical asymptote, then these two curves are really never going to touch. But the thing is, even though it looks like they're never going to touch, so it seems like they're never going to touch, they don't ever really touch, you can still get a finite area, theoretically, as long as they get close enough together. So notice this did give me a finite area, even though it seems to me, since there's an asymptote, they're never really going to touch, they get close enough together that you can get an area. All right, sorry, so boring. So sorry. Rewatch the video if you have to at home. Here's the assignment, which is also written up on the board. Hope that went well, because I'm whooped. Bye, y'all. See you tomorrow.